Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. In this video, we are going to address the region filling, a topic from the 10th chapter of digital image processing, the chapter titled Morphological Image Processing. Morphological image processing is basically a switch from where we first of all used to have the input images and the outputs also in the form of images. Now onwards, the input definitely will be the image as the subject digital image processing, and further the output can be either the image or the extracted features information from it. Up till now in this chapter, we have gone through the understanding of the fundamental morphological image processing operations as like the dilation, erosion, opening, closing. The various properties with respect to these operations we have addressed along with few MATLAB programs also. We are also dealt with the hit or miss transformation, and in the previous videos we have gone through the boundary extraction. Now let us have the understanding of what exactly the region filling is. So here let us develop an algorithm for the purpose of region filling, which will be based on the set of functions like the dilation, making the complementation, and the intersections. Now we shall view a figure. So in this figure we shall be having the 8 connected regions, and we shall be using it for the purpose of region filling algorithm. So here we shall begin with only one point represented by P inside the figure there, and our objective will be to make a complete region filling with the help of ones represented into the figure. So on the right hand side you see the figure. In the part A we find a set represented by capital A. In the part B, the corresponding complement for the same set is also represented. Next to that, in the part C, we have the representation of the structuring element B. So here for the region filling algorithm, the set A, its complement, and the structuring element B, these are the inputs, while we proceed forward from the next part D up to the end so that we get the region filled output here. In the part D, we find initial point inside the boundary. From E to H, we have the various steps represented, and in the part F, we have the final result. So in this process, if we assign the non-boundary points, that means the background points with the zeros, then we can assign the value of 1 to the P represented into the region. Let us have the following procedure that fills the region with the help of ones. So here we represent the equation. The equation is represented onto the left hand side with the capital X to the suffix K here, and it is computed as the intersection. So the intersection with the first input that has been represented into the bracket. So bracket has X suffix K minus 1 that has the dilation operation corresponding to the given structuring element represented by capital B. So this bracket has the intersection with the complement of the capital A. So to the power of capital A representing the complement, we have small c there, where the values of the K ranges as 1, 2, 3 and so on. So here X suffix 0, if it is the case, it will be equal to the region point represented by P, and B, the symmetric structuring element that we have already shown into the last figure, part C. Now let us have the algorithm to terminate with the iterative step if X suffix K is equal to X suffix K minus 1. The set union of X suffix K and the set capital A contains the filled set and its particular boundary. Now there it is the role of the dilation process. The dilation process with the represented equation would fill the entire area surrounding to the point if it is unchecked. However, the intersection of the each step with the A complement that has been represented at the right extreme limits the result to the inside of the region of the interest there, so that the region filling will be a controlled one. So now this is the one example of how exactly the morphological image processing can be conditioned to meet the desired properties here. So it is appropriately called as conditional dilation also. Although this example has only one subset, the concept clearly shows that any finite number of such subsets, assuming that a point inside each boundary is given to us. So let us address one example under the heading region filling. So we shall be visualizing a figure in that a part shows an image that has been composed of white circles with the black inner spots. An image such as this might result into the thresholding if the two only levels for a scene containing the polyspheres, for example the ball bearings, will be. The dark spots inside the spheres are the result of the reflections. The objective here is to eliminate the reflections by the use of region filling. Now the figure A that shows one point selected inside another spheres that we see, and the figure B shows the result of the filling that component. Finally, the figure C shows the result of filling all the spheres here. So these are the figure part A, figure part B, and figure part C from left hand side to right hand side. So here we find onto the right hand side there is no dark spot inside the spheres. So the objective is accomplished with the help of region filling. Now let us address a region filling problem. So here the input image and the structuring elements can be shown with the help of the figure, where we perform the region filling operation here. So see here, onto the left hand side we have a structure that represents the input image. In the middle we have the complement of the input image, whereas onto the right hand side we have a symmetric type of the structuring element that can be represented by capital B. So here we go for performing the step number 1. Here the computation representing the x suffix 0 can be as below. So now we perform the dilation operation for x suffix 0 with the structuring element B here. The resulting image is then intersected with the complement of the input image. So this completes the first iterative loop here. So this is the exact visualization what we have performed into the step number 1. Onto the left hand side we find the representation of x suffix 0, the first phase here that has a dilation operation with the structuring element represented by capital B, the input here, and this is the corresponding result. We further make intersection with the complement of the input image. So finally this is the outcome of this step number 1 onto the right hand side. So initially we had only one point that has been represented by the dark color here, whereas the output of step 1 gives the 2 pixels with the color dark. Now let us have the second step in the region filling problem. So here the input of the second step is the result of the first iteration that we have just now obtained. The process performed into the step number 1 is to be repeated here. So here we visualize, we initially have the 2 dark pixels and again we have the dilation operation onto it. Whatever the result we obtain, in this result, see the number of dark pixels have been increased because of the dilation. So dilation operation is basically the local maxima operation, and such intermediate result is further intersected with the complement of the figure A here, or the input. So now we find the output of the step number 2. So instead of having the only 2 pixels with the dark color, here we have total 4 pixels with a symmetry represented by the dark. After step number 2, we go for solving the step number 3. The same process is to be repeated again, but the input image here for this iteration should be the output of the step number 2. So here we continue with the output that we obtained into the step number 2. Now here we have the 4 pixels represented into the dark. We perform the dilation operation with the same structuring element, and now the dilated result is further intersected with the complement of the input image. Finally, here we find total 7 number of pixels represented into the dark color. So after step number 3, we go for solving the step number 4, where the steps followed into the 2 and 3 are to be repeated here. The resultant image can be shown below. So here the result from the previous step number 3 is again dilated. We find the dilated result, and it is to be intersected with the complement of the input image, and finally we get the output of the step number 4. So here total 8 pixels are shown into the dark color. Now we go for opting the step number 5 after completion of step number 4. The input to this step number 5 will be the output of step number 4. The process done into the step number 4 is to be repeated in the step number 5. So here we have the total 8 black pixels arranged that we obtained into the output of step number 4, that is to be dilated here. Then the dilated result is to be having the intersection with the again the complement of the input image. Finally here we obtain total 10 pixels that have been represented with the dark color here. After step number 5, we have the step number 6. The input to the step number 6 will be the output image from the step number 5 here. The process done into the step number 5 is to be repeated in the step number 6. So the visualization shows you the 10 dark pixels represented into the input here, that is to be dilated. So the dilated output from this process will be having the intersection with the complement of the input image, and finally here we have the total number of 12 pixels represented into the dark color. So after step number 6, we have the step number 7. So now we perform the union of the result obtained into the step number 7 with the original input image to get the region filled with which can be shown into the figure. So here this is the output from the previous step, and this is the input image. We carry the union operation on both these inputs, and the result of whatever the process we have opted from step number 1 to step number 7 is available to us onto the right hand side. This is the region filled here. So I hope the understanding of the region filling is very clear to you people. By the next lecture we shall be addressing the next topic from the same chapter, Morphological Image Processing. The topic is titled Extraction of Connected Components. I hope you enjoy learning the digital image processing. For more information and knowledge of the subject, you can subscribe to Ekeeda channel. Thank you.